अरे वो स्टार्ट हो गया. So, good morning everyone. So, we are in the second class of our CBC, and in the first class, we have already discussed with different types of matter. We have discussed fundamental particles of electron, and on that basis, we will be discussing the homework question DPP1. चलिए पहले देखते हैं which property of an element is always a natural number. So, natural numbers are, what is a natural number beta? Natural number is a counting number, right? So, natural number will be a counting number. The question is asking which of the property of an element will be a natural number. That means that will be just an integer. What can be an integer? Atomic volume. Atomic volume can be in a fraction. For example, if I say 1 mole of any gas, 1 mole molecule of any gas, its volume will be 22.4 liter, right? So it is 22.4 liter, that means it's not a natural number. Now let's go for the atomic weight. Atomic weight can be in a fraction. For example, if we talk about the atomic weight of helium, it will be 4.003, it is a fraction, right? Atomic number, it will always be an integer. So the correct option for question 1 will be C. Let's move to the next question. The smallest particle of matter that can take part in a chemical reaction. What is the smallest particle that can take part in a chemical reaction? Now, when we talk about the smallest particle, right? We are talking about the smallest particle. Then two things comes into our mind. First is atom, and second one will be molecule, right? So when we are talking about the smallest particle, there are two things. One is atom, one is molecule. Now atom is the smallest particle that takes part in the chemical reaction. So it is the smallest particle that will take part in the chemical reaction, and molecule is the smallest particle that can exist in nature. Okay. Now for a simple example, if I take O2, in nature, in air, oxygen will exist as O2. The air that you breathe in, that is O2, right? And it consists of two different particles, that is O and O, that is our atom. Whenever one oxygen, let's say, whenever one oxygen is going for the chemical reaction, oxygen is going to react with hydrogen, what will happen? Will this oxygen go to react? No. First of all, it will break into two different atoms, and these atoms will go to reaction. So the smallest particle of a matter that can take part in chemical reaction, what will be our answer? A, that is atom. Okay, good enough. Now the third question, what is an example of homogeneous mixture? What is mixture first of all? What is mixture? Mixture is, if we are mixing 1, 2, 3, 4 different substances, that is our mixture. Mixture is a composition, is a solution, you can, not a solution, you can say any substance that consists of 2 or 3 different components. Now mixture is of two types. One will be homogeneous and one will be heterogeneous. What is homogeneous? Homogeneous means composition will remain same throughout the mixture, and heterogeneous means composition will remain different throughout the mixture. So if we talk about homogeneous mixture, let's say first of one, mixture of soil and water, is it correct? If we take a mud, will it have same composition? No, it can be different, so first option will be wrong. Mixture of salt and sand grains, is it correct? If you are mixing salt and a sand, it can be having same composition, can't be having same composition, so it is not sure to be a homogeneous mixture. Now let's come to be the third one, sugar solution. Now if I am dissolving 2 spoonfuls of sugar in a glass of water, what will happen? And after some time, after dissolving, any drop of water of the whole glass will have the same sweetness. Why? Because their composition is homogeneous, because the composition of sugar or the percentage of sugar throughout the solution will be same. That's why our answer we will go for sugar solution. These two are, this is homogeneous and these two will be heterogeneous mixture. Okay. So now let's move to the fourth one. Which of the following is not a mixture? As per matter, if you have studied about matter, so we have two type of thing. One is pure and one is impure. What is pure? If I have substance and it has same composition throughout, then it will be pure, right? And if the composition is different at any point of time, then it will be impure. So first one is gasoline. Is it pure? No. Gasoline consists of different types of gases. So it is not pure. It will be impure. It will be a mixture. Distilled water. Now if I talk about natural water, I have a glass filled with water. Is it pure substance? The water that we are drinking. Is it pure substance? No. Why? Because it consists of water. It consists of some dissolved gases. It consists of some dissolved minerals. So the natural water that we are drinking is not a pure substance. It is mixture, right? But if we are talking about distilled water, now distilled water means what? We have pure water, H2O, the whole substance will be pure. Is it a mixture? No. So distilled water will be a pure substance. LPG, the gas that we use, consists of 3 or 4 different gases, that is a mixture. Iodized table salt. Iodized table salt means it has NaCl, it has iodine into it. So it is also not pure, right now. So only pure substance that we have right now out of these 4 is option B. Okay? Chaliye, next. Which of the following is not an element? What is an element? क्या पढ़े बेटा अपन? Element is pure substance, right? That has, it is a pure substance that has only one type of atom, right? Only one type of atom. Okay? So, hydrogen, is it an element? Yes. Hydrogen will consist of only hydrogen atom. Yeah, hydrogen has different type of isotopes. That is okay. Hydrogen consists of 3 different isotopes. But all of them will have similar properties and all of them will have same atomic number. That's why it is an element. Oxygen element, nitrogen element. Is H2O an element? No. Why? It consists of hydrogen, it consists of oxygen. So it is a compound. So option D will be our correct answer. Next question is process of interconversion of solid to gas. A simple question. That means if I am converting anything from solid to liquid to gas. Okay? From solid to liquid, if you are converting anything, this is melting. This is liquid to gas is vaporization or evaporation, right? And if you are converting anything directly from solid to gas, then this is sublimation. Okay, so as per our question, solid to gas, what it is? Sublimation. If you are going from liquid to solid, then it will be solidification. And if you are going from gas to solid, then it will be condensation. So we have 4 terms out here. First one is melting, that is solid to liquid. Second one is evaporation, that is liquid to gas. Third one is sublimation, that is solid to gas. And fourth one is condensation, that is gas to liquid. So our option, correct option, we will go for option number C. Next one, which of the following is a mixture? We have already discussed. What is mixture, beta? Mixture is any impure substance, right? It is an impure substance that consists of 2 or more than 2 type of things or components. Milk, is it a mixture? Is milk a mixture? Yes. Milk will be a mixture. Why? It consists of protein molecules. It consists of carbohydrate molecules. It consists of water. So it is mixture of two or more than two substances. It is having two or more than two different components with different properties, with different identities, and that's why it will be a mixture. What is common salt? Common salt is a pure substance, that is NaCl. Now NaCl is a pure compound. It consists only of NaCl molecules, Na plus and Cl minus. Sugar, it's a compound, C12, S22, O11. And CO2, it is also a compound. So option B, C, D, all of them are compound, all of them are pure. So which is a mixture? Milk will be a mixture. Now next question. Out of the following, an example of matter which can be termed as fluid. What is fluid? Fluid is a substance that can flow, that has property to flow, right? So carbon, it is a solid. Sulfur exists in the form of S8 or S6, and it is also a solid. Oxygen exists as O2, it is a gas. Phosphorus exists as P4, it is also a solid. Now out of the four options given here, what we know, anything that is a liquid or that is a gas, that will be our fluid. Fluid, what is fluid? Any substance that will be a liquid or gas, that is our fluid, right? So here out of four we have three solid, only one oxygen is gas, it will be called as the fluid. Okay. Now question number 9. A form of matter that has no fixed shape but it has fixed volume. A basic question based upon solid, liquid and gas and their properties. Now if we talk about solid, what it has? It has a fixed shape and fixed volume. If we talk about liquid, it has fixed shape, fixed volume, only fixed volume, different shape, I am not writing that. Now gas has neither of them, neither a fixed shape nor a fixed volume. So out of this, any substance, what they are asking, that has no fixed shape but fixed volume, it goes for liquid. So we have to check out of four options what is liquid. Krypton, kerosene, carbon steel, carbon dioxide. Now krypton is our noble gas. Krypton is in the gaseous form. Kerosene will be in the liquid form. Carbon steel will be in the solid form. And carbon dioxide will be in the gaseous form. Now we can easily check what is our answer. Option B will be our correct answer. Okay. Question number 10. Which of the following is not a characteristic of solid? For a solid, what we have studied till now, molecules or particles are very closely packed. They have a strong force of attraction. They have fixed shape. They have fixed volume. Molecules are not free to flow. They are not a fluid. Right? So what is the property of solid? Is it rigid? Yes. They have a fixed shape, they have a strong intermolecular force of attraction, right? So it will be rigid, that is correct. Regular shape, yes. Molecules are not free to flow, that means all the molecules, all the particles will be at one place, that means they will have a fixed shape. High density, if the molecules are close, density will be high, so this one is also correct. High compressibility, what do you mean by this term compressibility? Any substance that can be compressed, that means volume can be decreased by applying pressure. So compressibility means what? You can decrease the volume by applying pressure. Now for any substance, if force of attraction are weak, for example I take a gaseous molecule, there are large intermolecular gap. That means if we apply the pressure, this intermolecular gap will decrease and overall volume of the gas will decrease, right? Right now, that means due to this, what we can say, gases are highly compressible. Now when you come to the liquid, then intermolecular gaps are smaller than the gas, but there are intermolecular gaps. That means that can also be compressed. But now, if I come to solid, molecules are closely packed. There is very small intermolecular gap. That means if you compress them, then decrement in the volume will be negligible. That means solid are not compressible. Solid can't be compressed, so it is not highly compressible. Option D will be our correct answer. Okay? So first 10 question we have done. Let's move to the 12th one. Ice floats on the surface of water because. Simple sa thing hai beta, if we have two substances in the liquid A and B, anything that is lighter, that will move up, anything that is heavier, that will settle down, and anything that is lighter will have less density, anything that is heavier, that will have high density. So if I am saying ice floats on the surface of water, that means what? The density of ice is lighter than air. Density of ice is less than water. That's why it floats on the water. Question number 13. The property of flow is unique to fluid. Which of the following statement is correct? The property of flow is unique to fluid. Fluid means what? Molecules are loosely packed. What happens? Understand this. What we term as fluid. Let's say I have some particles over here. Now what happens? They have very weak force of attraction between them. There will be some force of attraction. There can't be zero force of attraction, right? So now, as this one is a very weak force of attraction. Very weak force of attraction. Now, if the force of attraction is weak, then what will happen? Then this molecule is allowed to move. They can move a little, right? Even a little. So this, let's say these three molecules are moving on the right hand side and they come at this position. So the molecule on the rightmost side, this is moving towards this direction. Now as they will move, what will happen? A gap will be created, a column gap will be created. And due to this force of attraction, next layer of molecule will move over there to fill that gap. Now this is the reason of being a fluid. That one layer of molecule is shifting, and due to that weak force of attraction, the gap will be filled by the second layer, then by the third layer, then by the fourth layer, and that's why the whole molecule can move from, whole group of molecules can move from one point to another. So for being a fluid, what we know, gases and liquid both are fluid. Both can flow. Solid are not a fluid, right? Only gases behave as fluid. Is it correct? No. Liquid and gas both can behave. Gas and solid? No. Solids are not a fluid. Gas and liquid? Yes. Both are liquid. Option D says only liquid are fluid. Is it correct? No. This is partial correct. This one will be partial correct. This one is partial correct. Best answer goes for option C. Question number 14. Ice is floating on water in a beaker. When the ice completely melts, then the level of water in beaker edge. Now, it is a little bit interesting question. If I have water over here, ice will be something like this. 9/10 of the ice is inside the water, only 1/10 is up. Now, as per our concept, what we know, when our water is converted to solid, now this is liquid, this is solid. What happens? Volume increases. That means ice will have larger volume than water. Right now? The volume of water, volume of ice will be larger. But now we can also say a little bit. But we can also say that the volume that ice is occupying, that will be just a moment. That will be, let's say this is our pure ice. Okay. So volume that is occupied by ice, for that same amount water has been displaced. Now when ice will melt, that ice will go into that volume only. Whatever volume ice is occupying, that much amount of water has been displaced by ice, right? So on melting, that same volume will be filled, so overall volume will remain the same. Right now? So what will happen when the ice will melt? No new volume is created. That space that it has displaced, that will be filled. So overall volume will remain same. Question number 15. Okay, we have to match the column. Matter. What is matter, beta? Anything that, any substance that will occupy space, will have a volume, is known as matter. So made of small particles, we will go for this. Solids, incompressible. As we have discussed, solids have very small intermolecular gaps, so they can't be compressed. Solid CO2, it is known as dry ice. It's just a common name. Solid CO2. CO2 can be liquefied below 31 degrees Celsius, and that is known as dry ice. Plasma, fourth state of matter. What is plasma? If anyone asks in a simple language, in the base fundamental way, what we can say? Highly energetic ions. This is plasma, fourth state of matter. And gases, interparticle are low. That means for 1 we are going for C. For 1 we are going for C, B or D can be correct. For 2 we are going for A, 2A, 1C, 2A. Okay. 3 is B. Option B is our correct answer. Okay. Assertion, the solid do not diffuse in air. These particles are loosely packed in solid. See, first thing, solid don't diffuse in air. Why? Because they have a strong force of attraction. And if they have a strong force of attraction, they are closely packed, not loosely packed. So the first statement that it is saying is correct. But the second statement is just opposite of what first statement is saying, or on what first statement is based. That's why assertion is correct, reason is wrong. So option C will be our correct answer. Question number 17. High diffusibility of gas. Why? Why solid was not diffusible? Because it has a strong force of attraction, because molecules are closely packed. Now, if we have high diffusibility, that means what will happen? It will have very less force of attraction. If you have less force of attraction, molecules are far away. And if molecules are far away, then what will happen? They are free to move. They will have high kinetic energy. So option B will be our correct answer. Out of the following, which is densest state of matter? Not going to discuss it. This is the first basic thing that we study in matter. So answer will be solid. Which has least kinetic energy of molecules? Solid. Zigzag movement of the solute particle in a motion is known as Brownian motion. Chali, let's discuss a little bit of this. This Brownian motion was first of all studied for pollen grains. What happened when we kept pollen grains on a, if I am putting some pollen grains in a with water, what will happen now? Understand. The molecules of water are in constant motion. Molecules of water are free to move. They are not static. So what will happen? Let's say one water molecule will come and strike it in this direction. So due to this pollen grain will start to move. Now let's say it reached here. So another molecule can strike from here. Next molecule can strike from here. Next molecule can strike from here. So what will happen? The pollen grains will be struck by the molecules of water from random direction. Okay? Due to this, pollen grain will start to move. But that movement will not be in a continuous manner, will not be in a linear manner. It will be zigzag. Why? Because let's say if I have a pollen grain here and molecules are colliding from all the direction. Whichever direction there will be unbalanced force or collision, there we will have movement of the pollen grain. So pollen grain can move from any direction. This direction is not fixed. Now this motion is known as Brownian motion. Okay? So we have completed our DPP 1. Now we can start with DPP 2. So I think we have studied with this. Let's start with this. Which of the following is not a fundamental subatomic particle? What is subatomic particle? The smallest particle defined as atom. Okay. After atom, what in 1804 to 1808, this was discovered. Now after this discovery, till after 100 years, next atom was divided into 3 different particles. That means atom is made up of electron, proton and neutron, and these are known as fundamental subatomic particles. So what is not a fundamental subatomic particle? Positron will be our best answer. Positron is also a part of nucleus. But for fundamental subatomic particles, we will go for electron, proton and neutron. Charge of electron edge. Now electron is negatively charged and its charge is minus 1.602 into 10 to the power 19 coulomb. One more unit that you can have, 4.84 into 10 to the power minus 10 ESU. So charge on electron can be either of this or this. So our correct answer will go as minus 19 coulomb. This will be the charge on proton. This is wrong. Relative mass of electron. Relative mass of electron, if we talk about electron, proton and neutron, what is the relative mass of electron? It is 0.00054. So option A will be our correct answer. Isoelectronic pair. What was isoelectronic? Same number of electrons. Okay? Same number of electrons. That means a number of electron का formula क्या है बेटा? Is Z minus charge, where Z is our atomic number. So for calcium and potassium, calcium number of electron will be how much? Z, that is 20. Potassium how much? Z, that is 19. For B, argon. For argon, Z is 18. No charge, that means number of electron is 18. For calcium, Ca plus 2, 20. Z minus charge, how much? 18. So it is isoelectronic. Potassium and Ca plus 2, potassium is 19. Calcium will be 20 minus 2, that is 18. Not an isoelectronic. Same goes with D. So option B will be our correct answer. Triad of nuclei which is isotonic. What do you mean by the term isotonic? Isotonic means same number of neutrons. Isotonic is same number of neutrons. What is the number of neutron? Formula for number of neutron is A minus Z. What is A? A is atomic mass. What is Z? atomic number. So number of neutrons should be same. Carbon 614. What is number of neutron? 14 minus 6, that is 8. Nitrogen 714. 7, no. Now if we talk about carbon, okay, so I think there's a little mistake here, a little bit misprint is over there. Let's leave it, let's move ahead. Again, carbon 9715 doesn't make a sense. So here some options has been misprinted, beta. Option B and option C, we have a mistake over here. Okay, so we are leaving this option. What can be the correct answer? What should be over here? Let's see. It should be carbon 614, it should be nitrogen 715, and it should be fluorine 917. This misprint I think is there, so you can rectify it. Carbon 614, first option, first part of the option 3 is correct. Number of neutron 8. Carbon 715, this 9 is misprinted over here. So now it goes to be number of neutron to be 8. Fluorine 917, this is also correct, and this is again 8. So option C will be our correct answer. Same mistake I think here also they have done. That means carbon 714, nitrogen 714. This will not be an isotone. Here again, this is number 8, this will be 5, this will be 10. So this is also not a isotope, okay? Sorry, this is not also a isotone. By mistake I told it isotope. Question number 6. The correct statement about proton. What is proton? Proton is P plus, denoted as P plus, where atomic mass will be, atomic mass is, not atomic mass, mass of proton is approx 1 AMU, a little bit higher than that. Okay, it is a nucleus of deuterium. What is nucleus of deuterium? Nucleus deuterium is 1, 2. Deuterium is isotope of hydrogen, H12. Here we have 1 electron, 1 proton, 1 neutron, and these together will be our nucleus. So nucleus of deuterium has 1 neutron and 1 proton. So this is incorrect. It is an ionized hydrogen atom. Hydrogen atom, if nothing is given, is HH. Right? Hydrogen molecule is HH. Hydrogen atom will be H11. Now here I have 1 electron, 1 proton, 0 neutron. Now if I ionize it means what? I removed the electron. I converted it to form H plus. In this case, I will have 1 proton, 0 electron, 0 neutron. So it is representing nothing but a proton. So it is ionized hydrogen atom. Yes, it is correct. But is it a ionized hydrogen molecule? Is it H2 plus? No. It is atom. Single atom consists of 1 electron and 1 proton. If I have H2, it will have 2 electron, 2 proton. So if you ionize it, only proton will not be left. It is an alpha particle. What is alpha particle, beta? Alpha particle is denoted as 2, 4. Here we have 2 proton, 2 neutron, 2 electron. So in alpha, actually this one is He, helium, 2, 4. If you remove both the electron, then this will make a alpha particle. So alpha particle is doubly charged helium ion. So if I take an alpha particle, it will be He plus plus, where we will have 2 proton and 2 neutron. There is not, this is not a single neutron or single proton. So option D will also not be correct. Next, isotopes are, just basic definition. What are isotopes? Any substance that has same atomic number, different mass number. For example, chlorine 35 and chlorine 37. It is an isotope. Same atomic number, different mass number. Atom of different element having the same mass number. Different element, matlab atomic number is different. This is isobar, not isotope. So this one is incorrect. Atom of same element having same mass number. Same element, matlab same atomic number, same mass number. They are identical. Not valid. Atom of same element having different mass number. Same element having different mass number. What does it mean? Atoms of same element, that means Z is same. Different mass number, A is different. Same atomic number, different mass number. Option C is correct. Number of electron and neutron of an element is this, and this its mass number H. What is mass number? Mass number is number of proton plus number of neutron. Now, for any, if we talk about element, if we talk about element, for any element, I will better use a word neutral particle. Number of electron will be same as that of number of proton. If any substance is neutral, now in an atom, till now we have three fundamental particles. What is? Electron, proton, neutron. Neutron is neutral. Electron is negatively charged. Proton is positively charged. Right? Now, if the substance is neutral, that means number of electron and number of proton will be same. Number of electron will be same as that of number of proton. So, what it is saying, we have how many electrons are there? 18 electrons. That means number of electron equals to number of proton equals to 18 and number of neutron equals to 20. So, mass number will be 38. This is our correct answer. Nucleus of an atom contains, atom is made up of two particles, if I can say. One is nucleus, and outside nucleus we have electron. Better word that we can write is electronic cloud. That we will study from the next class onwards, orbit and orbital. So we have two particles, electronic cloud, it is consisting of electron. This consists of proton and neutron. So option C will be our correct answer. Lightest particle is alpha particle, mass will be approx 4 AMU, proton approx 1 AMU, neutron approx 1 AMU, electron approx 0005 AMU. I am saying approx. Why? Because neutron is little bit heavier than proton, slightly heavier than proton, but approximately both are 1 AMU. So which one will be the lightest? Electron is the lightest particle. Which of the following is isoelectronic with carbon atom? What was isoelectronic, beta? Isoelectronic means same number of electrons. So carbon is represented generally as this. We can have one more isotope of carbon. But if we talk about number of electron, so number of electron will be 6 in both the case. Carbon has 6 electron. So what we have to find out? Which of this option will have 6 electron, right? And what is the formula for number of electron? Number of electron is Z minus charge. Number of electron will be Z minus charge. Nitrogen 7 minus charge 1, that is 6. Oxygen 8 minus charge. Minus 2 is the charge. The charge is minus 2. So 8 minus of minus 2, that is 10. Sodium minus charge, that is 10. Aluminium minus charge, that is 10. So in fact, carbon is isoelectronic with nitrogen, and this option B, C and D, all of them are isoelectronic, but not with carbon. Right? B, C and D, all of them have 10 electrons, so they will be isoelectronic among themselves. Carbon is isoelectronic with nitrogen, so we will go with option A. Compared to the mass of lightest nuclei, the mass of an electron is. Now first thing, what is the lightest nuclei? Lightest nuclei, what we know, nucleus consists of neutron and proton. Nucleus has two things, but the lightest nuclei is of hydrogen. And hydrogen ka lightest nuclei will have 1 proton, 0 neutron. So lightest nuclei is, compared to the mass of lightest nuclei, the mass of electron is only approximately, okay, the mass of electron is approx 1 by 1837 or 1840, I will take round figure, times of proton. Okay, it's 1837 or 36. So electron is 1840 times of proton. So lightest nuclei of hydrogen is nothing but a proton. So I will go for option C, nearest answer. Which of the following atom does not have same number of proton and neutron in its nucleus? Same number of protons and neutrons. Let's talk about carbon. What it is? Number of proton. Number of proton, I was saying, na? Number of proton equals to Z. That means equal to 6. And number of neutron equals to A minus Z. That is also 6. So 6 proton, 6 neutron. Deuterium, 1, 2. 1 proton, 1 neutron. Number of proton equals to number of electron equals to Z in neutral, and number of neutron will be atomic mass minus Z. So that is 1. Tritium, it is H13. So 1 proton, 2 neutron. Nitrogen, we have, it is 714. 7 proton, 7 neutron. Okay, what they are asking? In which they are not same? Option C will be our correct answer. An isotone. What is isotone? In isoterms you have studied beta. Isotone is nothing but same number of neutrons. Right? It is same number of neutrons. And number of neutron formula what we have? Number of neutron formula we have A minus Z. Atomic mass minus atomic number. So just check it from here. In this case, 76 minus 32. What you will get? 44. So what we have to check? In which we are getting 44? Here we are getting 45. Here we are getting 43. Here we are getting 44. Here we are getting 42. Atomic mass minus atomic number. So option B will be our correct answer. Okay, number of neutron. Just a moment. Number of neutron in sulfur. What will the number of neutron beta? As per formula, what we have? A minus Z. Atomic mass minus atomic number. So number of neutron will be what? 32 minus 16. Option B. Table below shows the element P, Q, R, S. Identify the elements which are isotope, isobar, isotone, isodiapher. What is isotope? Same Z, different atomic mass. What is this? Different Z, same atomic mass. What is isotope? Isotone, same number of neutron. What is isodiapher? Same difference in number of neutron and proton. So what we have to check? Which of them is isotope? Which of them is isobar? Which of them is isotone? And last one, what is isodiapher? Difference between neutron and proton should be same. Right? Okay, they have given the options over there. Number of proton 11, 12, 11. First what we have to check? Okay, same Z. So obviously we can have this too. Atomic number should be same. For isotope, first criteria is atomic number is same. So number of proton is same as atomic number. So we have only two cases over here. So we don't need to check rest of the things. because P and Q will have same Z. Now number of neutron is different, that means atomic mass will be different. So P and R is isotope. P and R is isotope. We have two options over here. Let's cross check second one. Same atomic mass, matlab this addition should be same. Where it is 12 plus 12, 11 plus 3. What we are getting? 24. The atomic mass is 24, 24. But atomic number is 12 and 11. That means it is carbon, sorry, not carbon, it is magnesium and it is sodium. Any isotope, I am not talking about the element that is existing in nature. They have given a example, but atomic number, according to atomic number, this is Mg, this is sodium. They have different atomic number, but same mass number. So Q and R will go for isobar. Q and R for isobar. Now, isotone. Isotone means what? Number of neutrons should be same. Number of neutrons should be same, PQ. Difference in the number of neutrons should be same. That means neutron and proton. This minus this, 1. This minus this, 0, 2, 1. That means these two. N minus P, that is P and S. So option C will be our correct answer. 17th one, number of proton, neutron, electrons in actinium. We have no charge over here. So you can directly say number of electron equals to 89, that is Z. Number of proton equals to any time Z, that is 89. And number of neutron will be 281 minus 89. That will be, I think, 92. So number of proton, neutron and electron in the element actinium. Again, all the options are wrong. Here all the options are wrong, and I think we have done a small mistake over here. So option D will be our correct answer, but we have a misprint over here. So number of proton will be 89, number of neutron will be 92, and number of proton will be, okay, sorry, that was my mistake, 281, na it is. Okay, it is 192. This one is correct, beta. It will be 192 only. I took it to be 181. Okay. So for 17, option D will be our correct answer. An isotone of oxygen 16. Isotones means same number of neutrons. Same number of neutrons, that means how many neutrons? Here we have 8. So we have to check in which we have. Here how many neutrons we have? 9. Here how many we have? 6. Here how many we have? 8. Here how many we have? 17. So which one is an isotone with oxygen 16? Obviously third one, that is carbon. So option C will be our correct answer. Charge of neutron 0, not going to explain it. These are same atomic number, different mass number, that is isotope. So that's it. We have completed our DPP 1 and 2. So we will take a 2-minute break over here, then we will restart. एक बार pause कर दो आप. Note 5. Pause, once pause, no? Life में pause नहीं होता. Okay. What? So in the first chapter, we have few minutes left. So we will discuss a little bit about the basics that you have studied in the first chapter and what we are going to start after that. Okay. So till now, what we have discussed? Till now, I have discussed. In fact, what we have discussed, beta, we have discussed matter, right? We have discussed our matter. So we have discussed matter, different types of matter. We have discussed atoms, molecules. We have also discussed a little bit about homogeneous mixture, heterogeneous mixture. Then we studied about the fundamental particles of atom. Fundamental particles of atom. This you have studied. Now let's, right now in 10 to 15 minutes, whatever we have, we will just have a brief history of atom, how it started. Because from the next topic onwards, we have to enter into the structure of atom, orbit, orbitals, how electrons are arranged. So just have a brief history of this. From the next class, we will start the proper study of atom. Now, atom word was discovered in 1804 to 1808. By whom? By John Dalton. So John Dalton gave this word and he gave his own atomic theory, Dalton's atomic theory. He was such a famous scientist that till 100 years no one questioned him. And one more thing, that at that moment of time, we had not advanced to this extent that we can study an atom. Atom was a particle that was in our theory only. Right? So we were not able to study a atom, what it is made up of, how it looks, what its properties and all. The scientists at that time just gave a brief history of about that. Atom is the smallest particle, it will take part in chemical reaction, you can't divide it. And no one was questioning Dalton. In later 1800, in late 1800, after from 1815 to 1890, in this middle, scientists were working on how to conduct charge through air. What was the main concern? Main concern was, whenever lightning takes place, it gets conducted through air to the earth. But when scientists tried to conduct charge through air, what was our major concern? Scientists were working on conduction of charge through air. From where we were inspired? From lightning. And we were not working on atom. We had no clue that atom is indivisible or not, whether atom is made of smaller particles or not. What we started? We started working on this conduction of charge. And for this, you may have studied a very famous experiment, Franklin kite experiment. What Franklin tried to do, he flew a kite, and he tried to find out whether the lightning is exactly same as that of electrical charge, current or not. So he flew this experiment and he found that lightning is just a charge. So till 18 mid or 18 end, what we found? We found that we were working around? We were working on conduction of charge, and what we found, lightning is a charge, it conducts through air. In lab we were not able to do it. In 1896, two scientists were able to conduct the experiment, Gregor and Marsden. They were the scientists who conducted or who were able to have conduction of charge through air. In the lab, not in nature. So now charge was discovered. Now the first question or a basic question that comes in our mind, if I have an atom, it is the smallest particle and it do not have a charge. Atom is the smallest particle, it does not have a charge. Then any substance, and everything is made up of this. So any substance that is made up of atom must be what? Neutral. Now if there is charge, and later on we also study the properties and everything, if there is a charge, that means atom is not the smallest particle. There must be some particle smaller than atom that bears a charge. And so from there, scientists again started to work on the structure of atom, what is atom made up of. Okay, and in 1909 first discovery of electron was made by Thomson. So from 1800 to 1900, hundreds years, what happened? What was the progress in our science? That in chemistry, what happened? First atom was given. Till 50-60 years, no one questioned on it. Every scientist was working on conduction of charge. 1896, conduction of charge was done in the lab by Gregor and Marsden. From there, a question arises that is really atom the smallest particle? Or there is some other particle that is bearing a charge that can exist inside an atom? And 1909, J. Thomson first of all discovered electron. Now atom is neutral and it consists of electron. That means there must be some other particle, proton. And next particle discovered by proton by Goldstein. In fact, neutron was not a problem till then. No one thought of neutron even. Why? Because our first question will arise what? Ki atom is neutral and it consists of electron. It must have some positive charge particle, and that was discovered. That was proton. We were happy. Scientists were happy that atom is neutral. It consists of two particles, electron, proton, that's it. Okay, this all was happening in 1909. Now scientists were with a new question. What? Ki if it consists of electron and proton, how they are arranged? Okay, no one was bothered about neutron. So now what they started to study structure of atom. This is a big topic that we will study in class 11 in full detail. Right now, we will have just few points how it went. So structure of atom was first given by Thomson model. Or also known as plum pudding model. Okay, Thomson gave a model. He passed to his student Rutherford. Rutherford was the student of Thomson. He passed his model to Rutherford to prove that whether it is correct or not. But Rutherford, what he found, that this is incorrect. Okay, so then Rutherford, to check whether this is correct or not, did alpha ray experiment. And what he found, that his model is incorrect. After that, Rutherford gave his solar system model. Now, this was the time, you can say, where physics subject physics took a new turn. 1905 to 1910, where this was the region, this was the time period when physics was taking a new turn. When Einstein came and gave his 5 different papers on theory of relativity. According to him, he divided the whole world into 2 parts. He said there is a world in which we live, that is macro particle, that is a different world. And another particle, another world exists, that is micro particle. That was given by relativity theory. So now this solar system model was comparing an atom with our solar system, where solar system is a macro world, large world, and atomic structure is a micro world, a small world. So due to that difference of physics, you can say Newtonian and Einsteinian physics, this model also went wrong. And then we came up with the third model, that is Bohr's model, 1913. Where what? Niels Bohr, this is the model that we are going to study in detail, first model that we are going to study in detail. What he said, all the positive charge will be in the nucleus. See, this term nucleus was discovered by Rutherford only. He used it. So all the positive charge will be in the nucleus and electrons will revolve around nucleus will revolve around nucleus in fixed circular path. Fixed circular path. Okay. So what he discovered is an orbit. This fixed circular path is known as orbit. Fixed circular path is known as orbit. This was happening in 1913, and as I said, neutron was not a problem for anyone. No one was thinking about it. Why? Because we had neutrality of atom, and Bohr was studying hydrogen that consists of one electron and one proton. We don't have neutron over here. In fact, neutron was discovered 19 years later, 1932. Okay, na? So here the first model came up, and what it said, ki in an atom, all the positive charge is inside a very small volume known as nucleus, and electrons will revolve around it in a fixed path that is known as orbit. Okay, so till now we have discovered atom, we have discovered fundamental particles, and we have a basic arrangement of them, right? So should we continue? So we will keep till here only, beta. From the next class, what we are going to study, ki how we moved further from here. Okay, why we moved further, we are not going into the complete detail right now. That we will do in class 11. We will have just a fundamental concept and idea of different particles of atom. So bye everyone. We will have a 5 or 10 minutes break, and then we will have your next session for the next subject. So this will be a break. Movie break is there. You can go and enjoy.
Good morning to all of you. Yeah, again welcoming all of you on behalf of Resonance Group. This is my second class. Yesterday I have seen the comments. Okay, no? I was teaching according to our CBC book. All of you have CBC book, I think. Yeah. In that, a bit in depth, in more depth, I have taught you. For example, the first unit in that vector was there. Only vector definition is being given. I had explained you in more detail what is vector. Complete vector chapter I will be teaching you when you will be coming here. In our book, simply they have told you what is a vector. It has magnitude and direction. I have taught you even triangle law, parallelogram law. Simple, I have mentioned it. What is triangle law? What is parallelogram law? Which we need for addition of two vectors. For teaching even basics of kinematics, we need that, right? If you go for distance or displacement, a bit in more depth I have explained to you yesterday. One boy had asked from which page of CBC it is. It is page number 3 and 4. And along with that, yesterday I had given you homework. Complete homework I will be explaining to you. At the same time, you consider frame of reference. In our book, one of the finest book, Basics of Frame of Reference they have discussed. Yesterday, I have explained in more detail what is frame of reference, how many types of frame of reference we have, inertial frame of reference, non-inertial frame of reference, both I have explained to you. Yeah? So one boy had asked about which page I should follow. If you have CBC book, you can go from the beginning, page number 3 and 4 yesterday I have explained to you, and I'm a bit recapping today. Again, for those children who have not followed, who have not having any foundation. The first unit in kinematics was distance and displacement, right? What is distance? If a particle is moving from one point to other point, it means that you have initial position and final position. Whatever will be the length of the path, the distance of length of the path is considered to be distance of length of the path is considered to be distance, whereas displacement is concerned the directed line segment in between initial and final position is considered to be displacement. It is written in our CBC book. Okay, no? If you have CBC book, you can consider distance and displacement, studied, and let us take the questions based on distance and displacement. Distance is a scalar quantity. Simple language, again I am explaining to those children who have not followed. First, I have explained what is a scalar. A scalar quantity is that which has magnitude only. Vector quantity is that which has magnitude and direction. A car is moving on a road towards east with velocity 5 meters per second. 5 meters per second towards east is a vector quantity, it is velocity. Right? Distance depends upon length of the path. From initial position to final position, you can go via so many routes. Distance will be changing as you will change the path, but displacement will not change. Displacement only depends upon initial and final position, right? Distance will always be greater than displacement. Displacement will never exceed distance. Under only one condition, distance and displacement will be equal if particle is moving along a straight line path without return. Particle is going just along a straight line path. Suppose particle had gone from A to B. It is not returning. Along a straight line path it goes. So from A to B, distance covered and displacement will be equal. Displacement may be positive, may be negative, may be 0. Distance covered by a particle in a given time interval will always be, positive. For example, if the same particle had gone from A to B and again it is coming back from here and it goes to point C, the net displacement will be negative. If you take it as origin, this one you take positive x-axis, then this side will become negative x-axis, your displacement is negative. But distance covered, you will have to add A to B, this length, plus B to C, this length, you will be adding. Clear to you? So now, based on that, from same CBC book, I hope that all of you have, whichever child would not have, from nearby Resonance campus, you may get that. From that, I am discussing now the problem. I hope you are understanding what is distance and what is displacement. Question number 1, in case of a moving body, a body is moving, 4 alternate they have given you. Displacement greater than distance, displacement less than distance, displacement greater than equal to distance, displacement less than equal to distance. Now, you yourself tell me which is right. Undoubtedly, the fourth one, distance is greater than displacement. And in one case, distance will be equal to displacement. Are you understanding now? Is it clear to you? In these 4 alternate, fourth alternate is correct answer. Distance covered by particle in a given time interval will always be greater than displacement, and under only one condition, when particle is moving along a straight line path and it is not returning back, then distance and displacement will be equal. Tell me, did you understand this? If you understood this, then move to second question. Distance is always, number 1, A, shortest length between 2 points. This shortest length between 2 points will be your displacement. Path covered by an object between 2 points, product of length and time, none of the above. I hope you are understanding very well. Distance is the length of the path covered by an object between 2 points, so your answer will be B, path covered. It is actually the length of the path covered by any particle or object between 2 points. Tell me, understood this? Clear, no? Now, let us move to third question. Displacement is always positive, is always negative, may be positive as well as negative. is neither positive nor negative. Just now I have explained to you. Displacement may be positive. Particle is going from, this is positive x-axis. Suppose particle has started from origin and it has moved from O to A, displacement is positive. Right? It is moving again from A to B. Displacement depends only upon initial to final position. This is your initial position, this is final position, this side is negative x-axis. Displacement is negative. Suppose particle is moving from O to A and again it is coming back to O. Displacement will be 0. So displacement may be positive, may be negative, may be 0 in a given time interval. So here you see the correct answer may be positive as well as negative. So answer will be C. Hoping you are understanding clearly. Yeah. Next, move to fourth one. Which of the following is not characteristic of displacement? It can be positive. It has both magnitude and direction. Which of the following is not characteristic? It can be 0. Its magnitude is greater than or equal to actual path length of the object. First thing, displacement can be positive. Yes, it is correct. Displacement is a vector quantity, so it has magnitude as well as direction. It can be 0. Yes, it can be 0. The guaranteed your answer will be fourth one. Its magnitude is greater than or equal to. Yes, it may be equal to the length of the path. Yeah? But it will never be greater than distance covered. It means that they're asking you is not the characteristic, its magnitude is greater. This is wrong word. Displacement will never be, its magnitude will never be greater than distance covered. Tell me, followed na? If you understood this, I remember one boy Sonu had told, sir, for some topics you can explain in Hindi. My dear child, actually pan-India, from whole India, students are coming here and their mother tongues are different. We strictly follow, only English language. But when you'll be coming here in your campus, your teacher will certainly explain any concept personally in your own mother tongue. The child has asked me, sir, please a bit explain in Hindi. If you are coming near us in this campus, guaranteed I will explain to you personally in your own mother tongue. But whereas class is concerned, we will speak purely in English. Correct you? Now, come back here. Question number 4. Did you understand it clearly? Now, let us move to next problem. And it is from your CBC book only, SI unit of displacement. You know, again you will tell that some extra topic you are telling. Fundamental physical quantity in Newtonian mechanics. You know very well. Mass, length, time, thermodynamic temperature, electric current, luminous intensity. If you take SI, the unit for displacement is meter. Not only for displacement. In SI, International System of Units, in that even you will take length, distance, displacement, for all we use meter. In CGS system, you are using centimeter. In FPS system, you are using foot or feet if number is more than 1. So here, your answer will be meter. Clear to you? Now, next. In 5 minutes, the distance between a pole and a car changes progressively. What is true about the car? Car is at rest, car is in motion, nothing can be said with this information, none of the above. In 5 minutes, the distance between a pole and a car changes. When it is changing, and if they are asking about distance, if they will ask about displacement, I may consider that after some time it may be 0 also. But whereas distance is concerned, I have told you distance covered will always be positive, guaranteed car is in motion. Is it clear to you? So here your answer is car is in motion. Now next. Now we'll go for just 1 minute. I'll be giving you other questions. Kindly give other questions. This one will give. Yeah. Now, you consider this, a man moves. Now, problem I am considering. First, tell me, distance and displacement is clear to you now? Now we are doing the problems. A man moves 10 meter north and 20 meter east. Determine his displacement from initial position. Now, if you consider direction, this is north, this is east, south, west. Man moves 10 meter north. So from here, you are going 10 meter. It is 10 meter. Let us take, this is origin and particle had moved to point A. Then they say you, he had moved 20 meter east. Slowly, I am explaining to you. Today, I hope each and everything you will be understanding. Now, it has moved from A to B. This one they have given you 20 meter. Check. Man is moving 10 meter north. I have taken 10 meter O to A. Then he had moved 20 meter east. You see east, particle had moved 20 meter east. They are asking you displacement, undoubtedly from initial position. If they will ask distance covered, what will you do? You will add 10 meter plus 20 meter, 30 meter will become your distance covered. You want displacement. So this is initial position, this is final position. Directed line segment means this. Now displacement magnitude they are asking you. So the length OB will give you magnitude of displacement. You know Pythagoras theorem. If you take 10, 20, then OB will be equal to under root OA square plus AB square equal to under root OA squared 10 squared plus AB squared 20 squared. This will become root of 100 plus 400 root of 500. You can write it 5 into 100. This is 10 root 5 meter. Understanding now? Displacement is directed line, a straight line segment. Means you'll have to consider initial position, final position, join these two. Whatever will be the length of this straight line, that will give you magnitude of displacement. It will become 10 root 5 meter. And this is the answer. I hope all of you are understanding. If you are not understanding, you will be asking me later on. I will explain to you. Next problem. A wheel of radius 1 meter rolls forward half a revolution. Suppose I have a wheel. This is a wheel. Okay? It is like this. Suppose this point is A, this point is B. Now, they say you radius, they have given you 1 meter. It is rolling forward half a revolution. The half revolution means now it will move here. Okay, no. This point is A, now A will come here. And B will come here. Right? Now, they're asking you, find the magnitude of displacement of the point of the wheel initially in contact with the ground. Initially, which point is in contact with the ground? A. After half revolution, where point A has gone? It has come here. They're asking you magnitude of displacement. I told you the length of the straight line in between initial and final position. This is initial position. This is final position. So you will take this distance, A, B. Let us suppose this point is A dash and this is BA dash. Right now, in one revolution, wheel will travel how much distance? 2 pi r. You know, circumference, if radius is r, it will be 2 pi r. And this is diameter, this is 2r. Half revolution. So this distance will be equal to pi r. Now, you want displacement, that is the length of a straight line AA dash, how much it will be? It will be equal to under root AB squared plus A dash squared. This is pi r squared plus this is 2r squared. Now, pi r, they have given you 1 meter. So this will be equal to under root pi squared plus 2a squared. This will be equal to under root pi squared plus 4, and radius is 1 meter, so this will be meter. Please check the solution. Again, I am explaining to you. I have a wheel. I want today, whatever I am teaching, my every child should understand clearly. And I'm not going in too much depth as yesterday I have gone you. Okay. And I have taught you according to our CBC book. The difference is, in our CBC book, simply definitions were being given. I have explained those definitions in more depth. Today, from that same CBC book, because one child has asked me, please tell me, sir, page number. Now, it is completely page number also, I'm telling you, page number 3, 4, 5. You go through same concepts I'm explaining you, and in more detail I'm explaining you. Now you take this problem. I have a wheel. Again I'm telling for those children who have not followed. Now wheel is rolling. In one complete revolution, how much distance it will cover? It will cover 2 pi r. Then half revolution, how much linear distance it will cover? Pi r. So linear distance covered is pi r. A, B, pi r. And half revolution, the point which is in contact with the ground, it will go up. Now, if you take from here till here, this is equal to diameter. Diameter equal to 2r. Now, you want displacement. Displacement is the length of the line, na? The length, directed line segment in between initial and final position. The initial position is here, final position is here. Pythagoras theorem to you know na beta. Simple. This base, this is perpendicular, this is hypotenuse. Hypotenuse square will be AB square plus A dash square. Now, I want A dash, this will be under root AB square plus A dash square. AB pi r, A dash 2r, r they have given 1 meter, it will become pi square plus 2 square, pi square plus 4 under root. I hope my every child who is listening is understanding it clearly. See, for solving problem related to any topic, it is too much essential to understand concept behind the problem. Yesterday also I told, today also in brief, I have told you about distance and displacement, and all these problems are related to distance and displacement. I hope you understood it. If you didn't understand, also you openly tell me, I will be again explaining you. In our resonance, every faculty will be ready to help you in any way, whatever you want to ask. Right? Now, let us move to next question. An athlete completes one round of a circular track of radius 2 meters in 40 seconds. Find his displacement at the end of 2 meters. 2 minutes 20 seconds they are asking you. Yeah? An athlete completes one round of radius. If you take one round, I have taken one round of radius 2 meters. This radius they have given you 2 meters in 40 seconds. 2 meters in 40 seconds. Right? They are telling you 2 minutes 20 seconds. How much time you have? 2 minutes convert into second. 2 into 60 seconds plus 20 seconds. How much you got? This is 120. 2 minutes 20 seconds. Na? So, if you take 6 into 2, 120 plus 20, it is 140 seconds. Okay, no? Now, if you take 140 seconds, 2 meters in 40 seconds, 40 divide here, it is 120. It means 3 complete round. Okay, no. It has moved 3 complete round and 40 second 1 round. Athlete completes 1 round of radius 2 meter in 40 seconds. Then 40 second, 1 round, net displacement is 0. If you take 3 round, 120 second, how many round you got? 3 round, beta. In 3 round, okay, no, net displacement will be 0. In 1 round, from where it has started, again he has reached there. Second round, again he will reach that initial position. Third round, again he will reach to initial position. Then 3 round, his displacement is 0. Now, next we'll have to see how much time left. 20 seconds. Right now. In 40 seconds, he is giving 1 round. In 20 seconds, he will give half round. If you take half round, it means that from here, he will reach here half round. In half round, he will reach to diametrically opposite point. And this is the length of diameter. This is initial position, final position. 3.5. So if you take 1, 2, 3, and 3.5. Now you want displacement. 2 meter, total it will become how much? 4 meter. The net displacement will be 4 meter. But in the same problem, if they will ask you distance covered, then you will have to take 2 pi r plus 2 pi r plus 2 pi r plus pi r. Okay, it will become 7 pi r. 7 pi r will become 22 r. 22 r means 44 meter. Right? They had asked you only displacement. So displacement will be just 4 meter. You can check the key. It is 4 meter. I hope you are understanding it clearly. Yeah? Again, if you want 2 meter in, just to check, athlete completes 1 round of radius 2 meter in 40 seconds. 1 round means whatever is initial position, final position is same point. In 1 round, displacement is 0. So 3 round, any number of complete round, displacement is 0. Your timing here is 2, you see, 40 second timing, they have given you 2 minutes 20 seconds. 2 minutes means 120 seconds. 40 into 3. 1 round, 2 round, 3 round. It will become 0. Now, it means that we will have to compute displacement only for 20 seconds. In 20 seconds, check in 40 seconds 1 round, then 20 seconds half round. Half round means particle is moving from one point to diametrically opposite point. So displacement is length of diameter. Length of diameter, diameter equal to 2 into radius, 2 into 2, answer is 4 meter. I hope you are understanding today clearly. Now, let us move to next question. A body whose position with respect to its surrounding does not change is said to be in a state of. If position coordinate is not changing, they have given you rest, motion, vibration, oscillation. Undoubtedly, if position coordinate of any particle with respect to surrounding. Yesterday, in inertial frame, I told you with respect to Earth. So with respect to surrounding means with respect to Earth, whatever objects are there nearby. If it is not changing, it means that body is at rest. If its position is changing with respect to surrounding objects, then we will consider that body is in motion. Vibration, oscillation, those are related to periodic motion, we will study much later on. We have three types of motion beta: translatory motion, rotatory motion, oscillatory or vibratory motion. First we will be studying translatory motion, then we will study rotatory motion. At last, a particular type of oscillatory or vibratory motion we will study, that is known as simple harmonic motion. First, tell me, for this problem, answer is a position coordinate will not change with respect to surrounding, body will be at rest. Now, let us move to next question. A body is said to be in motion if its position with respect to surrounding objects remains the same. If its position coordinate with respect to surrounding object remains the same, it means that body is at rest. Its position with respect to surrounding objects keeps on changing, guaranteed body is in motion. Third, both A and B, none of these, those two are wrong. So answer will be, a body is said to be in motion if its position coordinate changes with respect to surrounding object keeps on changing, body will be in motion. Are you understanding? If its position is not changing, body is at rest. If its position is changing, body is in motion. Rest and motion are relative terms. Yesterday in the beginning I have told you these two are relative terms. It will depend upon frame of reference. The child has asked, inertial frame, non-inertial frame. Yes, yesterday I had explained in too much depth in our CBC book. Those are not being given. Simply they have discussed frame of reference. I have explained a bit in more depth. That's the difference. But we strictly follow our schedule, our book. Clear? Now, let us move to next question. Vector quantities are those. When I started teaching yesterday, I have told you about a scalar quantity and a vector quantity. I have not told you in more depth what is a vector. Simply if you talk about magnitude and direction, it is not so simple, beta. If only you take magnitude and direction, then velocity of light should be a vector quantity, na? But it is not a vector quantity. Water is flowing in a pipe. Velocity of water in a straight pipe, can you treat it as a vector quantity? No, it is not a vector quantity. Electric current, you have magnitude. In a straight wire, it will have direction, but it is not a vector quantity. When we divide a vector from a scalar, it should be a vector, but the stress restoring force per unit area in elasticity chapter you will be studying is not a vector quantity. So to understand clearly vector, so many things we need. Simply the word magnitude and direction from childhood days you have studied, that is not the correct definition. As you will be coming near us, we will speak about vector in more depth. A vector quantity should have only one point of application. A vector quantity will not have multiple points of application. If I walk along a straight line path, will you consider my velocity as a vector quantity? No. My hand will have some velocity, my nose will have some velocity. But if you vanish me, total mass of my body, you assume to be concentrated at one point, and that point is moving along a straight line path in one direction, then my velocity will be considered as a vector quantity. So many factors are there which you will have to consider. A vector quantity should have only one point of application. It will be acting only in one plane. It will not act at one time in multiple planes. So if I have a source of light here and light travels in all directions, you have multiple planes. So velocity of light, even though word is velocity, it is not a vector quantity. So when we say magnitude and direction, don't think that only these two words are sufficient enough to explain a vector quantity. When you will be coming near us, we will tell you in more depth about it. Even in one plane, a vector quantity is acting only in one plane. In one plane also there will be infinite orientation, infinite directions. A vector quantity will be acting only in one direction, in one plane. And above all, to express a vector quantity, you have to consider a frame of reference. Means there will be origin, there will be x-axis, there will be y-axis, there will be z-axis. Yesterday also I have told you. But whereas this question, simple question is there, a vector quantity are those quantities which will have magnitude as well as direction, both. So your answer will be magnitude and direction. I hope you are understanding today clearly. Now, let us move to next question. What is true about a scalar quantity? A scalar quantity had magnitude only. All fundamental physical quantities are a scalar quantity. Mass, length, time, thermodynamic temperature, electric current, whatever fundamental physical quantity you take, all are a scalar quantity. A scalar quantity will have magnitude only. For example, I take distance covered by particle in a given time interval is 5 meter. 5 meter is magnitude. Magnitude of a physical quantity is represented by a number associated with a unit, NU. N is number, U is unit. 5 meter, 5 is number, N. U is unit, meter. Speed, 5 meter per second. 5 is number, meter per second is the unit. If system of unit you are changing, okay, no, undoubtedly number is changing. For example, I have 5 kilogram rice. I am expressing in CGS system, in gram. It will become, same 5 kilogram will become 5,000 gram. The size of unit you decrease and will increase. So magnitude which you are expressing as N into U, and number U unit, N is inversely proportional to size of unit. So here, very simple question, what is true about a scalar quantity? A scalar quantity have direction also? No. A scalar can be added arithmetically. There is special laws for scalar addition. Scalars have a special method to represent. No. Scalar quantities can be added arithmetically. Clear to you? You have 5 kilogram rice, 10 kilogram rice, you add in that, it will become 15 kilogram. How you got 15? Just you have added it arithmetically. Clear to you? In vector quantity, when you are adding, I told you that you need triangle law, parallelogram law, all those in detail we will teach you in the month of June when you will be coming near us. Clear to you? At this time, simple distance, displacement, scalar quantity, vector quantity and all we are telling you. Now, let us move to next question. Example of vector quantities are velocity, yes, length, no, mass, no, speed, length, mass, all three are scalar quantity. Here, one is vector, two are scalar. Time, displacement and mass. Time is scalar, mass is scalar, displacement is vector. But if you take D, you have velocity, displacement and force. All three have magnitude and direction. A particle is moving with velocity 5 meters per second towards east. You have magnitude and direction is towards east. Displacement. A particle in a given time interval had moved 5 meters. This 5 meters is displacement. Force. Whenever you are exerting a force, it will have magnitude as well as direction. I am applying on a particle a force of 10 Newton along positive axis. It has magnitude as well as direction. So, for this question, examples for a vector quantity is velocity, displacement and force. Answer is D. My dear children, are you understanding this now clearly? Now, I move to next, if it is there, which of the following is not a vector? Undoubtedly, A itself is not a vector, it is a speed. My next topic, which I will teach you after distance and displacement will be speed and velocity. Right now? Speed is not a vector. Velocity already you know. Weight you know. The force with which Earth pulls a body, attacks towards its center, that force is the weight of the body. So it is acting towards the center of Earth. The weight is a vector quantity. Acceleration, already you know. dv by dt. Rate of change of velocity. Velocity is a vector quantity, then acceleration will be a vector quantity. When you divide a vector from a scalar, it should be a vector quantity. Exception is there. Just now I have told you about stress. It is neither a scalar nor vector, it is a tensor quantity. Understanding, no? So which of the following is not a vector? Undoubtedly your answer is speed, velocity, weight, acceleration, all three are vector quantity. Now, let us move to next, if it is there. Time is an example of, I have told you, all fundamental physical quantities are scalar quantity. So, time is a fundamental physical quantity. When you will be coming, I will be asking you a simple question. Define time. You will think about it. What is time? And then you will be telling me. Everyone is thinking about time. One of the most precious things. You should never waste time. Whoever will give importance to time will only get success in life. But what is time? Think. Okay, no? Define time and you'll discuss with me. It's not so easy. A child has asked, sir, why you are wasting time by asking question on time? But it is a fundamental physical quantity. We should know about time now. In relativistic mechanics, time can be dilated. We can go to past, we can go to future. So many movies you have seen based on this. There would be time machine. Don't think it is hypothetical. Theoretically, it is possible. Time can be contracted, time can be extended. But at this time, we will take in Newtonian mechanics, time as a fundamental physical quantity. We can't go to past, we can move only from present towards future at this time. Just simple concept, time is a fundamental physical quantity in Newtonian mechanics and it is a scalar. Okay, no? If when you will grow up, when we studying in higher classes, when you will study relativistic mechanics, their time will not be a fundamental physical quantity. Clear to you, na? At this time, time is an example of a scalar quantity. Is it clear to you? Now, let us move to next question. Out of energy and acceleration, which is a vector. Energy in work power energy chapter, you will be studying the capacity to do work is called energy. All three quantities are scalar. Okay? And you know acceleration, rate of change of velocity. Change of velocity is the direction of acceleration. Right now? Change of velocity by time. A vector quantity divided by a scalar quantity, which is a vector quantity. Undoubtedly, they are asking you which one is vector. Undoubtedly, acceleration is vector. Your answer is acceleration. Energy is a scalar quantity. I hope you are understanding this. Now, let us move to just here, it's over. So all I want to now start, okay? Now a new topic, all the questions related to distance and displacement I have explained to you. And from our book, from CBC book, one child was telling, please tell me, sir, from which CBC book? CBC book page number you tell, sir. All page numbers also I have told you, and questions for homework which I have given, all questions I have explained to you, and classwork problem also I have explained to you. All questions related to distance and displacement I have told you. This is for only concept building. Don't think that questions are not only this much. Number of problems will be infinite beta in any topic. Okay, no? Highly typical problems will also be based on distance and displacement, but basic problems I have explained to you today. Now, let us move to next topic. You have learned first unit, distance and displacement. Now, I want to start speed and velocity. Now, I want to talk about speed and velocity. Right? Simple language. Speed is a scalar quantity, velocity is a vector quantity. Speed is distance by time. Distance covered by particle divided by time. Velocity is displacement by time. Displacement covered by particle in unit time is known as velocity. So if you take displacement and speed, if I take speed scalar, this is distance covered divided by time, and if you take velocity, this will be equal to displacement, because displacement is a vector quantity. Displacement by time. Sometimes children are thinking that velocity is rate of change of displacement. No, beta. It is rate of displacement. It is not change of displacement. It is rate of displacement, means displacement by time. Now, you will have uniform velocity and non-uniform velocity. You take velocity, magnitude, and direction. If in equal interval of time, a particle will have equal displacement, then you will say that particle is moving with uniform velocity. Means you take different time, equal time interval. If in equal time interval, if particle will have equal displacement, then you say that particle is moving with uniform velocity. More simple definition if you want, then simple. Velocity has magnitude and direction. If with time, magnitude of velocity vector and its direction will not change, means magnitude and direction remains constant, remains same, it will not change with time, then you will say that particle moves with uniform velocity. But if magnitude, either magnitude or direction or both of velocity vector will change with time, then you will say that particle moves with non-uniform velocity. For example, I have a freely falling body. Direction is same. It is moving downward only. But magnitude of velocity vector is changing with time. You know, velocity will be going on increasing. So, a freely falling body is moving with non-uniform velocity. Direction is constant, but magnitude is changing. Now you take circular motion, uniform circular motion. In uniform circular motion, magnitude of velocity vector does not change, but continuously direction is changing. I give you all. If there is a freely falling body or a body projected vertically up, velocity is non-uniform because magnitude is changing. Magnitude of velocity vector is changing, so it is non-uniform velocity. If you take circular motion, uniform circular motion beta, in uniform circular motion, you will have, magnitude of velocity vector constant, but direction is going on changing. Here, direction is constant, magnitude is changing. Here, your magnitude is constant, direction is changing. So, in uniform circular motion, particle has non-uniform velocity. Now, third you take simple harmonic motion. You take the bob of a simple pendulum, it is executing SHM, simple harmonic motion. At mean position, magnitude of velocity is maximum. Magnitude is changing, direction is also changing. So in simple harmonic motion, velocity is non-uniform because magnitude and direction both of velocity vector are changing. I have given you 3 examples. In first example, velocity is non-uniform because magnitude is changing. In second example, I have told you because velocity is non-uniform because direction is changing even though magnitude is constant, And in simple harmonic motion, if you consider both magnitude and direction of velocity vector is changing, all three examples of non-uniform velocity. Is it clear to you? The simple, I have introduced today what is speed, what is velocity, what is uniform velocity, what is non-uniform velocity. Tomorrow I will continue from here. Strictly, completely from our CBC book. I hope all of you have CBC book. We will strictly follow our book. You know that in resonance, not only student teachers, they strictly follow rules and regulations, strictly follow the schedule. In our CBC classes also, we are strictly following the schedule. Thank you to all of you for today, and mainly others, Sonu, all these boys who are frequently speaking, please, you'll tell me how have you felt today. I hope that today everything you understood. Even yesterday, whatever you didn't understand, today I have explained to you. Still, if you have doubt, my dear kids, you frequently tell me. In my next period, I will explain to you. Thank you for today. Have a nice day.
Good afternoon, everyone. Good morning, everyone. Okay, so we'll discuss the homework. Yesterday we have given, right, worksheet day 1. I hope all of you have completed the homework, and today we'll be discussing the homework. Okay, so let's do the first question. Just a minute. Okay, so the first question is number of prime numbers less than, I think this we have already done. This question we have discussed yesterday only in class. The number of prime number less than 10 is P and the number of composite number less than 15 is Q. Then P plus Q, I think the answer was A, right? Oops. The answer was A, right? We have already done this, so I am not repeating this question. Today we'll start with the second question. So what is the second question? Let P and Q be the number of natural numbers which are less than or equal to 20 and are prime and composite respectively. Then 20 minus P minus Q equal to what? Right? So P are the number of prime numbers, right? And Q are the number of composite number, right? So if I subtract 20, all the prime number and the composite number, what number it will be left? It will be left only 1, right? Because 1 is the only number less than 20 which is neither prime nor composite. That's why the answer will be what? 1. Okay, so it is marked as A, so the answer is what? 1. Okay. Okay, the third question, what it is saying, if x and y are prime numbers which satisfy x square minus 2y square equal to 1, then x comma y is equal to what? In this kind of question, what you can do, you can actually substitute the values of this x comma y and just check, right? So if I check for option A, I'll be getting 9 for option A, right? I'll be getting 9 minus 2 into 4, right? Which will be equal to 1. So that is correct. Right, option A is correct. Now let's check option B and C also, right? Let's see option B and C are also possibility or not. So if I check option B, I'll get 4 minus 2 into 9, which will not be equal to 1, right? That's why option B is not correct. Now let's see option C. For option C, if I write, I'll get 25 minus 2 into 49. Again, it will not be equal to 1. So the only option which is correct is what? Option A. Why are we checking option B and C? Because suppose in the question if option B and C appears first, then we need to check till option A. That is why we are checking till option, all the options. Okay, let's go to the next question. Number of ordered pair of integers p comma q for which q square equal to p square plus 14, right? How many number of pair are there? Ordered pair are there for which q square is equal to p square plus 14. So what I can do here is, I can get here p this side. So I'll get q square minus p square equal to 14. It means q minus p, right? And q plus p will be equal to 14. Correct? Now this 14 will be equal to 2 into 7, right? So obviously p plus q will be more than q minus p. So that's why we can say that q plus p, right? Q plus p will be equal to 7 and q minus p will be equal to 2. If I add them, I'll be getting 2q is equal to 9, right? So q will be equal to 9 by 2. How much? Q will be equal to 9 by 2. But what are they saying? They are saying it has to be an integer, right? 9 by 2 will not be an integer. 9 by 2 will not be an integer. So that is why we will say that there is no possibility. There is no possibility. There are zero ordered pair for which q square equal to p square plus 14. Okay. So I hope this is also clear. Option A is the correct answer. Right. Let's go to the next question. the total number of prime numbers among first 20 natural numbers is, right? First 20 natural number. So let's list them. So first is 2, then 3, then 5, then 7, then 11, then 13, then 17, and then last is 19, right? So 1, 2, 3, 4, 5, 6, 7, 8. So the answer is what? 8, right? This question is very simple, right? So just list down all the prime numbers less than 20 or till 20. So the answer what we'll be getting is at 8, okay? Anyway, yesterday I told you just check for 6n plus minus 1, right? 6n plus minus 1, those number will only be your prime numbers, okay? Now let's do the next question. Among the first 15 natural numbers, find the number of pair of twin prime numbers, right? First 50 natural numbers, find the number of pair of twin primes. What are twin primes? Yesterday only we discussed two prime numbers whose difference is what? 2. Whose difference is 2 will be known as what? Twin prime numbers, right? So the first pair which I'll be getting is 3, 5. Right? Second pair will be 5, 7. Right? Second pair will be what? 5, 7. Then after 7, which prime number will be coming? 11. So 11, for 11, 9 will not be pairing, but 13 will be, right? So I can say 11 and 13, right? 11 and 13. After 13, which number will be coming? 17, right? So again, 17, 19, right? 17, 19. Then after 19, I will be having 23. 23 as the prime number. But then for 23, neither 21 nor 25 is a prime number. So that's why it is not going to be coming, right? After 23, the next number will be 29, right? The next prime number will be what? 29. So 29, for 29, 31 is a prime number, right? 31 is a prime number. 27 is not, but 31 is. So that is why 29 and 31. Then for after 31, we have 33, which is not a possibility. Then 35 and 36, no, 37, right? For 37, if I check, I am not having 35 or 39 as a prime number, right? Then I have 41, right? I have 41 and 43, right? 41 and 43. Both are what kind of numbers? Prime numbers, whose difference is how much? Whose difference is 2. That is why we'll say that they are twin primes. So all these pairs have how much? Difference as 2, right? After 43, the next prime number will be what? The next prime number will be 59, I guess, right? Which is more than, anything will be more than 50. Apart from all the numbers, we have listed. So that's why the answer will be what? 6. Understood? Am I clear? Okay, let's do the next question. Consider the following statements. All prime numbers, right, are odd numbers, right? All prime numbers are odd number. This statement is not true. Why this statement is not true? Why? Because 9 is an odd number, but it is not a prime number. So that's why first statement is wrong, right? Okay. Second statement, there are only 5 single-digit prime numbers. There are only 5 single-digit prime numbers. So let's check for single-digit. So 2, 3, 5, and 7. 9 is not a prime number. So second option is also wrong, right? There are only 4 single-digit prime numbers. Okay. Then third, there are infinitely many prime numbers. That is exactly true, right? There will be many prime numbers, which we infinitely many, right? We can keep on checking, and then it will be increasing only. So that is why third option is correct. Okay. And then last option. What is the last option? A prime number has only 2 factors. That is a basic definition of prime number. What is the definition of prime number? That it has 2 factors. One, the number itself, and 1, right? So that is why this is also correct. So the correct options out of all this is what? C, third and fourth, right? I hope it is clear for everyone. 7th also. I hope all of this you have got correct. Okay, all of this you have got correct. The next question: the sum of first 8 prime numbers divided by 7 first 8 prime number divided by 7 is equal to what? Okay, so we'll list all the 8 prime number. I think we have already listed. We know it will be less than 20. Okay, so 2, 3, 5, 7, 11, 13, 17 and 19. You can add all of them and then divide with 7, right? Let's see what you will get. So 2 plus 3 will be 5, 5 plus 5 will be 10, 10 plus 7 will be 17, 17 plus 11 will be 28, 28 plus 13 will be 41, 41 plus 19 will be how much? 60, and 60 plus 17 will be how much? 77. So if I divide 77 by 7, I'm going to get what? 11. Understood? It's pretty simple. Just list all the prime numbers and add them and then divide by 7. As the question itself is saying, to divide it with what? 7. Okay, then let's do the next one. The average of consecutive even numbers is 24. What is the difference between the largest and the smallest numbers? So this is an interesting question, right? What is the difference between the largest and the smallest number, right? So the average of consecutive even number is 24, right? So we can say that the two numbers, see, one number is 24, right? One number is 24. Then I can say, if I go just behind this, right? What I'll get? 22, and if I go here, it will be 26. If I divide with, all this is a consecutive numbers, right? And if I take an average of this, right? If I take an average of this, what I'll be getting? 22 plus 26 will be how much? 48. 48 plus 24 will be how much? 48 plus 24 will be how much? 72. And 72 divided by 3 will be how much? 24. Right? Now what are they saying? What is the difference between the largest and the smallest number? So if I subtract 26 minus 22, I'll be getting what? 4. Right? I'll be getting what? 4. So the answer is what? 4. Okay? Alright. Next. There are 4 prime numbers taken in ascending order. Okay, they are taken in ascending order. The product of the first 3 prime numbers is 1771. Right? How much? 1771. Okay. 1771, and the sum of last 2 prime number is 82. How much? 82. Okay. Now what is the product of the last 2 prime numbers? Okay, what is the product of the last 2 prime numbers? Alright, so what I'll say, let the numbers be what? A, comma B, comma C, comma D. A, comma B, comma C, comma D. And they are saying the product of the first 3, means A, B, C is equal to how much? 1771. Right, 1771. And the sum of last 2 prime number, what will be the last 2 prime number? C plus D. Right. C plus D is given to be how much? 82. Okay. Then what are they saying? What is the product of the last 2 prime number? That is what they are asking for, C and C into D. Right. That is the question. Am I clear? So in this kind of question, there will be one more question of similar to this level. So this kind of question, what I'll do, I will first factorize 1771. Okay. 1771. Now 1771 is a symmetric number, right? It is symmetric number. So we'll say it is divisible by what? 11. Okay, I can clearly see that it is divisible by what? 11, right? So if I factorize 1771, I'll get here 11. So 1, and then I'll be getting 67. So it will be 6, and then one more here it will be 161. Right, 161. So 161. Now let's see, 161 is a product of which 2 prime number? Okay, so it is not possible of 2. For 3, if I check, again it is not possible. For 5, it is not possible because the number is unit digit is 1. Then I'll check for 7. Right, if I check for 7, it is divisible by 7. Right, because 7 2's is 14, and then 2 will be remaining, so I'll get 23. Right, and 23 is a prime number. right? So I'll get 11, 7 and 23. Okay, so if I compare ascending order, if I want to write in ascending order, I can say that A is how much? A is 7, right? B is what? 11, and C is what? 23, right? C is what? 23. Now I need to check for, if I have C, I have one more equation they have given. What is that? C plus D is equal to 82. Okay, so I can write it here and I'll get 23 plus D is equal to 82. So D will be equal to how much? 59, right? D will be equal to how much? 59, and 59 is a prime number, right? So I can say here D is 59. So 23 into 59, whatever number the product will be, is going to be how much? 1357. Understood? If we got the first, all the 4 prime numbers, we can definitely get the product of the last 2 prime numbers, which is going to be 23 into 59, which is 1357. Okay, I hope it is clear to everyone that how to do this kind of question. Okay, let's go to the next question. Find the difference between the largest and the smallest 4-digit number formed by the digits 0, 1, 4 and 7. Okay, without repeating the digits, using all of them at a time. Okay, so see, without repeating the digits, this is a very important information. Okay, and the digits what they have given, are what? 0, 1, 4 and 7. Out of this, 0 is very special. Why? Because if I want to find the largest number, right, then obviously I will write all the digits in the descending order. So the largest number will be what? 7410, right? Largest number will be what? 74. Just write in the descending order. Means from the biggest number to the smallest number. Correct? But if I want to write the smallest number, right, by the same logic, then what will happen? I will be getting 0, 1, 4, 7, which is not correct. Right? Why? Because 0, 1, 4, 7 is actually a 3-digit number, right? And what kind of digit we want? 4-digit numbers, right? So for 4 digits, what I'll do, I will just exchange 1 and 0, right? So the smallest number will be what? 1, 4, sorry. The largest number will be, oops, just a minute. The smallest number will be 1047, right? And if I subtract these two, this number and this number, what I am going to get? 6363. Okay? So if I subtract them, I am going to get 63 and 63. Okay? I hope this is clear to everyone. 11th question again. Then next question. Which of the following statement is not correct? Okay? Please mind it, they are saying not correct. Okay? So there will be 3 statements in this question which will be correct. And we have to identify which of them is not correct. Let's read one by one. Sum of even and odd number is an odd number, right? This we have done yesterday only. Odd plus even will be definitely odd. If we add any 2 kind of similar number, right, then we get, if we add any 2 kind of similar number, we'll get an even number. And if we add 2 different kind of number, that is 1 odd and 1 even, then I'll be getting an odd number, right? Then I'll be getting an odd number, right? We can take an example also for this 2 and for this 3. So we'll be getting 5. So this is correct, right? This is a correct statement, and we need to find not correct statement, right? So this is correct statement. Second one, sum of 2 even number is an odd number. This is incorrect, right? Because sum of 2 even number, 2 plus 4 will be 6, right? Which is an even number, right? So this one is definitely not correct. Right? This one is definitely not correct. Let's check option C. The sum of 2 odd number is an even number. I already told you that if we add any 2 kind of similar numbers, then whether odd or even, the number is going to be what? Even. Okay. So this is also correct statement. Then the last one, product of an even and an odd number is an even number. right? Yesterday I told you if we have even one even number also in the product of many numbers, then the ultimate product is going to be what? Even, right? If it is going to be even, then we can say it is correct, right? So the out of all these three statements, which is just which is not correct? Option B. So that is going to be the right answer for this question, right? That is going to be the right question for this question. Okay, next. The sum of two numbers is equal to 20 and the difference is 16. I hope this kind of question you have already done in 10th standard, right? In chapter linear equation, okay? So in this kind of questions, what do? We'll write let the two numbers be x and y, right? So what have they given? They have given x plus y is equal to 20 and that difference, that is x minus y is equal to 16, right? Just add them, so you will get 2x will be equal to 36. So x will be equal to 18. If x is 18, y will be equal to 2. What are they asking? What is the ratio of these two numbers, right? If I do the ratio x by y, I'm going to get 18 divided by 2, which is 9:1. So the answer is D, right? Answer is D, 9:1. All right. I hope it is also clear. 13th. Next, there are 4 prime numbers written in ascending order. Okay. There are 4 prime numbers written in ascending order. The product of the first, this is similar to the last one what we have done, so I'm not doing it. I hope all of you will get the answer, right? So this is very easy, so I'm not doing it. I think if the numbers are 13 and the product of the first 3 is 5, so just do it. 385, right? If I divide with 5, I'm going to get 7 and 77. So it is going to be 7 and 11, right? And that of the last 3 is how much? 1001. So if you multiply, if you divide 1001 with 77, right? I think you are going to get 13. Okay. So the numbers are what? I think 5, 7, 11, and 13. It is very similar to the question what we have done. I think that one was more difficult because the numbers were little bigger in that question, right? Okay, let's go to the next question. I think the last question. The positive integers a, b, a minus b, and a plus b are all prime. Then the sum of these 4 prime numbers is what? This is a very thoughtful question, that what 2 prime numbers I need to choose a and b such that their difference and their sum both are going to be what? Prime. Okay. So what I'll do in this, we can check for 2, 3. For 2, 3, 3 minus 2 will be 1, which will not work. So I will check for 2 and 5. Right? Yes. So 2 and 5 is a prime number. Then 5 minus 2 is also a prime number. And 2 plus 5 is also a prime number. Okay. Then what they are saying, the sum of these 4 primes are what? So if I add them, 2 plus 5 plus 3 plus 7, what are we going to get? 7 plus 7, it is going to be 14, and 14 plus 3 is 17, right? So 17 is what kind of number? Prime number. All right. So I hope all the question is clear now, right? There is no doubt in any of the question. If you have any doubt, as I have mentioned yesterday, that after the lecture gets over, from 2 to 5, you can go to the nearest center and you will find a doubt faculty there, and you can clear your doubts there with any of the faculty. Okay. If suppose in some question you are not able to understand, then please go to the nearest center and discuss with the respective faculty. Okay. Now we'll go for today's topic, the new topic, which is rational and irrational numbers. Okay. So we'll go to that. Okay. Okay, so the first thing what we are going to discuss today is rational and irrational numbers. Okay, they are very important, irrational numbers. Okay, so what are rational and irrational numbers? First thing first, rational numbers are represented by what? Capital letter Q. I have told you yesterday only. And irrational numbers are denoted by what? Q dash. Okay, so rational and irrational numbers, it is denoted by capital letter Q, and this is denoted by capital letter Q dash. Okay, now what is a rational number? I already wrote the definition yesterday. Any number of the form P by Q, right, where P and Q are integers, right, such that Q does not equal to 0, right? This is a plain definition of a rational number. Any number of the form of P by Q where P and Q are integers such that Q does not equal to 0 is what? A rational number, right? So all the integers, right, fractions, terminating and recurring numbers, right, all these numbers, all this will be coming under which category? Rational numbers. Okay, so please, example of rational numbers are, example of rational numbers, -2, -3, -5 by 3, right, -5 by 3. -5 by 3 is a fraction also, and it is a recurring number. Okay, -5 by 3. So all these numbers will be our what? Rational and rational number. Okay, now we'll go to the next set of numbers, which are irrational numbers, which are very important. So let's go to the next set of numbers, which are irrational numbers. So what are irrational numbers? Irrational numbers, which is denoted by what? Q dash. Okay, Q dash, always remember this. Okay, and now what are these? Non-terminating and non-recurring numbers, right? Non-terminating and non-recurring numbers are known as what? Irrational numbers, right? For example, I told you yesterday only, any prime number written in the form of inside a root, square root, cube root, will be giving you what? A irrational number. So for example, √2, right, √5, okay, and then 1 plus √2, right? All these are what? Example of irrational number. Okay, why? See, √2 is clear, √5 is clear, but why 1 plus √2 is an irrational number? Because sum of a rational and an irrational number is always going to be a irrational number. Okay, sum of a, this is a rational number and this is a irrational number. So sum or difference of this will be what? Always a, this is always going to be a what? Irrational number. Okay, sum or difference, irrespective of that. Please be mindful of this fact. Okay, apart from this, there are two very special irrational number, which is known as, one of them is pi, other one is what? E, right? Pi, anyway, you know, it is approximately equal to 22 by 7, right? Or we say it is equal to 3.14, right? Approximately equal to, right? And what is E? E is Napier's constant. Its value is approximately 2.713. It's going to be coming in the next, when you join the classes, when we will be learning about log, that time we'll be learning about E. Okay, so E is a very special irrational number along with pi. So these two you have to remember their approximate value. One is 2.713 and other one is 3.14. Okay, now I'll write one important note. What is a note? That sum of two numbers, one rational and one irrational, is always going to be irrational. Okay, is always going to be irrational. Okay, please be mindful of this fact that it is always going to be irrational. Okay, all right. 0, if somebody says what 0 comes in, 0 will come under the category of rational number. Okay, all right. Let's go to the next slide. I hope all this thing is clear about rational and irrational number. Okay, then we'll do, yes. Okay, there is one more note, second note. If A is a rational number, right, and B is a irrational number, if A is a rational number and B is a irrational number, and their product, AB is coming to be rational, it is only possible when A is equal to 0. Why? Because, for example, let's say A equal to 2 and B equal to root 2, right? Then their product AB will be equal to 2 root 2, which will be always irrational, right? But if their product is going to be rational, that is possible when there is only one rational number which multiplied with an irrational number will give me a rational number, and that number will be what? 0. That number will be what? 0. Understood? So that is why if the product of two numbers, one rational and one irrational, is going to be a rational number, then the rational number is 0. Okay, this is the second fact which you have to remember. Okay, then third. Okay, I think third one is not needed. Now we'll go to the algebraic identities part. Okay, this is very crucial. Okay, so till now we have learned about all the kind of numbers. Rational and irrational number we have already learned yesterday, but I have told you that we'll be doing questions on this, or we'll go again learn this today. So that is why I have revised rational and irrational numbers. Now we are going to learn something which is very important, very crucial for your foundation. Okay, for a IIT JEE, that is what? Algebraic identities. Okay, so that is, let's understand them. Some of you, I think you must be knowing also, but some of you which you are not knowing will understand it. So algebraic identities, right? Algebraic identities, right? The first one, very basic, I think all of you know this, that A plus B whole square is equal to A square plus 2AB plus B square, right? A square plus 2AB plus B square. Second, A minus B whole square will be A square minus 2AB plus B square. Okay. Third, A square minus B square is equal to A minus B into A plus B. I think all these three, all of you must be knowing and very much confident about this, right? But after this, like cubic identities, I don't know how many of you are able to remember, but it's okay if you don't know it right now. But whatever I am writing from today, please write it down in your notes and start learning it from today only, because these are going to be very crucial in solving each and every question. They will be used in many places. So please learn them as soon as possible. Okay. So the next one, fourth. Okay. Fourth one, A plus B plus C whole square, right, is going to be how much? A square plus B square plus C square plus 2 AB plus BC plus CA, right? A square plus B square plus C square plus 2AB plus BC plus CA. This is still the square. Okay. Now we are going to go for the cubic one. Before going to be cubic, I'll add one more here. That half of, or not even half, I'll say A square plus B square plus C square minus AB minus BC minus CA will be equal to half of a minus b square plus b minus c square plus c minus a square. Okay. This is also a very important identity which is used in many questions for IIT JEE. Okay, so which is of a square, so please remember them. And if anybody wants to know a proof of the fifth property or the fourth property, you can go to the respective center and ask any faculty. Okay, all right. So this is all about the squaring properties. Now I'll go to the next one, which is cubic. Okay, now cubic is somewhere where many people struggles a lot for cubic. Let's learn them one by one. First, for this is cubic, right? Cubic identities. Okay, so a plus b whole cube. A plus b whole cube is equal to what? A cube plus 3a square b plus 3ab square plus b cube. Okay, a plus b whole cube. Second, a minus b whole cube. A minus b whole cube will be a cube minus 3a square b plus 3ab square minus b cube. Okay, plus 3ab square minus b cube. So this is the second one. Third one, a cube plus b cube. Now for a cube plus b cube there are two identities. So you need to remember both of them. One is what? A plus b into a square minus ab plus b square, right? A square minus ab plus b square. And the second one is a plus b whole cube minus 3ab into a plus b. Okay, so this both of them you have to remember for the third one, a cube plus b cube. Okay, then fourth, for fourth, a cube minus b cube, right? It is going to be a minus b, a square plus ab plus b square, right? A square plus ab plus b square. And then in the other format it will be a minus b whole cube minus it is going to be plus 3ab a minus b. Okay, it's going to be a minus b whole cube plus 3ab a minus b. So this is all about the cubic one. There are few more which I'm going to add in the next slide. I hope you have copied all of this, and all this are very important. Okay. Okay. Then the next one, fifth, I think, in the cubic. Fifth is that a cube plus b cube plus c cube minus 3abc. A cube plus b cube plus c cube minus 3abc is equal to a plus b plus c, is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca, right? A square plus b square plus c square minus ab minus bc minus ca. Now this thing we have seen somewhere, right? Just in the previous slides, if you remember, I have written here, right? I told you already, okay, this will be used in many places. So a square plus b square plus c square minus ab minus bc minus ca is equal to what? Half of a minus b square, b minus c square, and c minus a square. So, right? So from there, if I can use that, I can say it is also equal to a plus b plus c into half a minus b square plus b minus c square plus c minus a square. All right, so these are two formulas for this particular thing, and there is a note for this also. Note. What is a note? Note is that if either a plus b plus c is equal to 0 or a equal to b equal to c, then a cube plus b cube plus c cube will be equal to 3abc, right? See what it is saying. If either of this or this is 0, right? see, a plus b plus c is 0, it means the right hand side will become 0. If right hand side becomes 0, then minus 3abc can be sent on this side, and it will become what? Equal to 3abc. First thing. Second is that if a equal to b equal to c, if a equal to b, this is 0, b equal to c, this is 0, and c equal to a, this is 0. So the overall this will become 0. Again, I can send this minus 3abc on that side, and it will become what? 3abc. Understood? This is a very important note. Please be mindful of this. Apart from this, there is one more identity which is useful in many questions, okay, which I think is not given in your book. But those who are watching only, they will be knowing it. What is the identity? That we can do it as an example also, okay, or you can write an identity that a to the power 4 plus a square plus 1 is equal to a square minus a plus 1 and a square plus a plus 1. Okay, a to the power 4 plus a square plus 1 is equal to a square minus a plus 1 and a square plus a plus 1. Okay, so let's prove this. Okay, I'll give you 2 minutes to prove this identity. Okay, and then I'll solve you. I'll show you how to solve this. Okay, how to prove. Please try to solve this question. Please try to solve this identity. Please try to solve this all the identities. Okay, I'll give you a hint also to solve it. What is the hint? That you take this as one term, a square plus 1, and a and minus a as another term. Okay, this is a hint. Okay, try to do it. Then apply the formula of a plus b, a minus b. Okay. I think you will get it. If those who are doing it, they will definitely get it from here. Okay, I think enough time given. Let me solve this. So what I'll do, I will write it to be equal to, in this way, a square plus 1 minus a and a square plus 1 plus a. Okay, now, see, if I consider, let this be what? X. And this be what? Y. Again, this is what? X, and this is what? Y. So what it is written? X minus y and x plus y, which will be equal to what? It will be equal to x square minus y square, which will be equal to a square plus 1 whole square minus a square. So if I expand this, I'm going to get a to the power 4 plus a square plus 2a square plus 1 minus a square. So if I solve, I'll get a to the power 4 plus a square plus 1, which is nothing but this, right? This is same as this. Understood? A to the power 4 plus a square plus 1, this is 8. This is, we have proven this identity, okay? But this is also an identity. You have to remember this, right? I'll again write it here to remember the last one, okay? But it is not least important. What is that? A to the power 4 plus a square plus 1 is equal to a square minus a plus 1 and a square plus a plus 1. Okay, so since you guys are all at home, right, you can start learning or remembering these properties, these identities from today only. Otherwise, you will find it very difficult to understand it in future. Okay, so please, it's my request, humble request, that start remembering all these identities, because it is going to be used in solving many questions. Okay, all right. Now let's see how we can manipulate some of these identities to get some value form. Okay, so let's understand the value form, some of the value forms. Okay. Right, value form. The first one, see, we know that a square plus 2ab plus b square is equal to what? A plus b whole square, right? If I send this 2ab on that side, can I say a square plus b square is equal to a plus b whole square minus 2ab, right? A plus b whole square minus 2ab. This is the first value form. Okay, so whenever they have given you a square plus b square, they have asked you a square plus b square, you can use this value form. Okay, second one, we know that same thing we can do for minus also. So a square minus 2ab plus b square is equal to what? A minus b whole square. Again I will send to this side. So I'll get a square plus b square is equal to a minus b whole square plus 2ab. Okay, so in this way also we can write. Alright, so if I want to combine this, we can write in combination also, but I think it will be confusing for you people. So just remember this particular format. Okay, now next one, third one it is saying that a minus b whole square, right? A minus b whole square is equal to actually a square plus b square minus 2ab, right? A square plus b square minus 2ab. And just now we have seen that a square plus b square can be written as a plus b whole square minus 2ab. So if I use it the next slide, right here, if I use this, so what I'll be getting? A plus b whole square minus 2ab and minus 2ab. This minus 2ab is coming from here, right? So it will become finally what? A square plus b square minus 4ab, right? A square plus b square minus 4ab. Okay, so we can also say that modulus of a minus b is equal to square root of a plus b whole square minus 4ab. Okay, I think I have made a mistake here. What is the mistake? It is a plus b whole square minus 4ab. Understood? Now some people will not be sure about what is this modulus. Okay, this sign actually stands for modulus. Okay, what it is not right now of the syllabus part, but this is the correct way of writing it. Okay, so I'm not going to explain what is modulus right now. It will be confusing for a lot of you. So, but just understand that this is the right way of writing this. That's why we are writing. Okay, modulus, and sometimes we also say it as absolute value. Absolute value. Okay, absolute value. So this is about mod of a minus b. If I want to write the same thing in mod of a plus b, then what I can do? It is equal to square root of a minus b square plus 4ab, right? Mod of a plus b equal to what? Square root of a minus b square plus 4ab. So please remember this few value form also, a minus b whole square, right? So this is the third particular value form which is going to be used in solving the questions. Okay, I hope this is clear. Let's go to the next one. Okay, the next one, fourth one. Fourth one is C. If they have given us a square plus 1 upon a square, right? A square plus 1 upon a square, then we can write it in multiple ways. Okay, we can also write, see, if I add 2 and subtract 2 in this, if I add 2 and subtract 2 in this, what it will become? A square plus 2 plus 1 by a square and minus 2 I am keeping it outside, right? So this is actually nothing but a square plus 2a into 1 by a plus 1 by a square minus 2 is here. Now this will become a whole square, right? This will become a whole square. This will become what? It will become a plus 1 upon a whole square minus 2, right? A plus 1 upon a square minus 2. Similarly, if I just instead of, I can also take minus 2 instead of 2. So what it will become? The same thing, a square plus 1 upon a square will be becoming a square minus 2a into 1 upon a plus 1 upon a square plus 2. What I have done, instead of taking plus 2 inside, I have taken what? Minus 2. Okay, so this will become what? This will become, now it will become a minus 1 upon a whole square plus 2. Okay, so the same thing, a square plus 1 upon a square can be written in two ways, right? One way is this, the other way is this. Okay, so please remember this also. It is useful in many of the questions, how to get the a square plus 1 upon a square. How, this is basically manipulations. Okay, so please remember this one. Alright, I'll write it once again here for your easy purpose. A square plus 1 upon a square can be written as a plus 1 upon a whole square minus 2, and it is equal to a minus 1 upon a square plus 2. Okay, in both the ways we can write the same thing depending on what is given and what is asked in the question. Okay, so please remember this also. Okay, I know I'm asking a lot of things to remember, but this is what is the requirement. These identities are very basic things. It's like very basic tools, fundamental tools to solve the complicated questions. So all of these identities are going to be used somewhere or the other. So that is why please learn them as soon as possible. Again and again, I am stressing on the same point. A lot of students, what they do, they don't, they think that a teacher is saying, there is not going to be any use for this, and we are going to learn it later. But the later never comes up, right? All the students just keep on postponing, and they start suffering. First of all this is, whatever we are learning is nothing of 11th or anything high level. This is our basic stuff. I think all of you must have learned this in 9th or 10th standard only, right? But if you have forgot something, or if you are conceptually you're not that strong, then only we are keeping it as a revision kind of stuff, right? So please remember them. The point is, please remember them as soon as possible. Whatever we have done today, whatever identities we have done today, please remember them as soon as possible. Okay, and the next one. I think this all are enough, right? There is nothing more to this. Okay, there is one more thing. The same, see, a cube plus 1 upon a cube, right? If this same thing I need to apply, yeah, I need to apply a square plus 1 upon a square. Same concept I need to apply for cube. Then what I'll do, right? Consider this to be, for this to be a, yeah, x. Okay, consider this to be x, right? And this to be y. So what it is written? It is written as x cube plus y cube. And I have given you a formula of x cube plus y cube, or a cube plus b cube. What is the formula? X plus y whole cube minus 3xy into x plus y. Right? Now we know what is x and what is y. X is what? A. And y is what? 1 upon a. So if I substitute, what will I get here? A plus 1 upon a whole cube, right? Minus 3 into a into 1 by a into a plus 1 by a, right? Now a and a will cancel, so you will be only left with, a plus 1 upon a whole cube minus of a plus 1 by a. So finally my point is here is that a cube plus 1 upon a cube will be equal to what? A plus 1 upon a whole cube minus of a plus 1 upon a. Right, this is another value form which you have to remember. Okay, again I am saying it will be used in solving the questions. Okay, similarly, if I want to write in terms of minus, right? If I want to write in this term minus, so next is, if I want to write, now you guys tried a cube minus 1 upon a cube. Right, you guys please try a cube minus 1 upon a cube. What will be the answer for this? A cube minus 1 upon a cube. Just try to apply the same concept what we have learned so far. Okay, again the same kind of concept. You can directly remember the result also, or you can apply the concept. So it will be a minus 1 upon a whole cube plus, I think here I forgot here 3, 3 will be coming, plus 3 a minus 1 by a, right? So this is for a cube minus 1 upon a cube, and this is for a cube plus 1 upon a cube. Okay? So now let's do some examples based on this identities, whatever we have learned. Okay, now let's do some example based on this. Okay, all right. What is the first example? First example is saying if A and B are two rational numbers, right? And A by B, A plus B, A minus B are also rational, right? Then A by B. Here they have given AB, right? They have given AB. Then A by B is option A, always rational, right? Option B, never rational, right? Option C, rational when B does not equal to 0, and option D, last one, rational when A does not equal to 0, right? So think for a while, what is the right option for this? They are saying A and B are two rational numbers, and AB, A plus B, A minus B are all rational. Then A upon B is what? Is going to be always rational, never rational, rational when B does not equal to 0, and rational when A does not equal to 0. So the correct answer for this, it's a very conceptual question. See, both A and B are rational, right? So in rational number, the only thing we need to check that any fraction will be rational when the denominator is not 0, right? If the two numbers are rational, then their fraction is going to be a rational number. Only thing is that the denominator cannot be a rational number 0, okay? Because 0 is also a rational number, so that case we have to eliminate. So that is why the correct answer here is going to be C. Okay, I hope this is clear to everyone. This is a very basic conceptual question. All right. Okay, now this is an interesting question. Question is what? If x plus 1 upon x, x square plus 1 upon x square equal to 23, right? Then find the value of x plus 1 by x, x minus 1 by x, and x cube plus 1 by x cube. So I'll give you 2 minutes to think of the identities, whatever we have learned so far, and start solving these questions, right? x square plus 1 upon x square is 23, right? This number is what? 23. Then find the value of x plus 1 by x, x minus 1 by x, and x cube plus 1 by x cube. Which identity you have to use? I hope everyone has copied the question. So try to use these identities. this one, right? Both of this. Okay, please try to do this. Okay, so what I'll do this. See, we know x square plus 1 upon x square, right? X square plus 1 upon x square can be written as x plus 1 upon x whole square minus 2, right? And can also be written as x minus 1 upon x square plus 2, right? Now, let's first use this one. Okay, we know this is given to be how much? 23. So 23 is equal to x plus 1 upon x minus 2 whole square. So can I say 23 plus 2 is going to be x plus 1 upon x square? So I can say 25 is equal to x plus 1 upon x square. This implies x plus 1 upon x is going to be plus minus 5. X plus 1 by x is equal to what? Plus and minus 5. Okay, and if I use this 2, right? If I use this 2, then I can say that 23 is equal to x minus 1 by x whole square plus 2. So I can say 21 is equal to x minus 1 upon x whole square. Or I can say finally x minus 1 upon x modulus is equal to plus minus square root of, oh, if I apply modulus, then I don't need to take 21, right? So I can say x minus 1 upon x is going to be plus or minus square root of 21. Okay, this is about the 2. Now last one, think about the last one, how you will solve x cube plus 1 upon x cube, right? Last one, try to solve x cube plus 1 upon x cube. Okay. See how we will do x cube plus 1 upon x cube is, we know x cube plus 1 upon x cube is equal to what? X plus 1 upon x whole cube, right? X plus 1 upon x whole cube minus 3 into x plus 1 upon x, right? Minus 3 into x plus 1 upon x. And we have already found that x plus 1 upon x is equal to 5 or minus 5, correct? So if I take 5, if I take it to be 5, I'll get 5 cube minus 3 into 5, right? Which is 125 minus 15, which is going to be how much? 110, which is going to be how much? 110. And if I take minus 5, right, then it will be minus 5 whole cube plus 3 into minus 5, right? Sorry, this is going to be, minus, so it will be minus 125 plus 15, which is going to be minus 110, right? There are two options for x cube plus 1 upon x cube, 110 and minus 110. And last, think for, so this question can come for higher degree also. If they ask you x to the power 4 plus 1 upon x to the power 4, now what you will do? X to the power 4 plus 1 upon x to the power 4, okay, and they have given you that x square plus 1 upon x square is equal to 23, right? X square plus 1 upon x square is equal to 23. Then what you will do? Okay, so see, just this is a square of square, right? X to the power 4 is a square of square. So what I can do, I can just square this. If I square it, I'll get x to the power 4 plus 1 upon x to the power 4 plus 2 into x square into 1 upon x square is equal to 23 square. This and this will cancel. So you'll get x to the power 4 plus 1 upon x to the power 4 plus 2 is equal to 529, right? So x to the power 4 plus 1 upon x to the power 4 is equal to 527. Right? It is equal to what? 527. All right. Now, very interestingly, I am giving you one homework. Think about, it will be coming in your worksheet also. Think about how will you get the value of x to the power 5 plus 1 upon x to the power 5. Okay. This is a homework. So we have done for x plus 1 by x. We have done for x square plus 1 by x square, x cube plus 1 by x cube, x to the power 4 plus 1 upon x to the power 4. But now I am asking you what? X to the power 5 plus 1 upon x to the power 5. How you will do this? Please remember that. Sorry, please do it at home. Okay. Now we'll do the next question. I hope this is clear to everyone. Okay. Then we'll do the next one. What is the next question? The question is, if a plus b plus c equal to 9 and ab plus bc plus ca is equal to 23, right? ab plus bc plus ca equal to 23, then a square plus b square plus c square equal to what? A square plus b square plus c square equal to what? Okay, try to use an identity. Okay, this also we have learned. Today only we have done this identity. So what will be, what identity will be used here? Which identity will be used here? In square we have done, right? So we can say that a plus b plus c whole square is equal to what? A square plus b square plus c square, right? Plus 2 into ab plus bc plus ca, correct? We know what is the value of a plus b plus c. So it is going to be 9 square is equal to a square plus b square plus c square plus 2 into 23. So 81 is equal to a square plus b square plus c square minus 46. So from here I'll get a square plus b square plus c square is going to be 81 minus 46. Right? This is going to be how much? I think 35. Right? Yes, it's going to be 35. So a square plus b square plus c square is equal to what? 35. Okay. All right. I hope this question is also clear to you, everyone. Okay. If you are copying, please copy. And let's go to the next question. Okay. I think this is the last example for today. Okay. Okay. If x minus y cube plus y minus z cube plus z minus x cube, okay, is equal to k times of x minus y, y minus z, and z minus x, then k equal to what? Then k equal to what? Think of this. We'll wait for 2 minutes. Think of this, how we will solve this question, right? X minus y cube plus y minus z cube equal to k x minus y, y minus z, z minus x. Then k will be equal to what? Think of this. Try to relate it with a cube plus b cube plus c cube equal to 3abc, right? Try to relate it with it. But there was some condition for that, right? We can't always write a cube plus b cube plus c cube equal to 3abc. There is a condition when and only when a cube plus b cube plus c cube equal to 3abc. I gave a note also. Okay, so please try to revise it. What was the note? The note was, if a cube plus b cube plus c cube is equal to 3abc, when A plus B plus C is equal to 0 or A equal to B equal to C, right? So in this case, if I say x minus y to be A, y minus z to be B, and z minus x to be C, right? X minus y to be A, y minus z to be B, and z minus x to be what? C. Then can I say that A plus B plus C will be equal to what? X minus y, y minus z plus z minus x. This will be equal to what? 0, right? It means that A plus B plus C is 0. It means that A cube plus B cube plus C cube is equal to 3ABC, right? So I can say that this value K is 3ABC. So the answer for this will be K equal to 3. Okay, the answer for this will be what? K equal to 3. Understood? This kind of question you can expect. Now for today's homework is worksheet number 2. Okay, it's on page number 57. I'll write the homework. Page number 57, worksheet number 2, right? Worksheet number 2, I think all the questions you can do. Yes, all the questions you can do, all 15 questions. Okay, page number 57, worksheet number 2. This is a homework. Please do it for proper understanding. Don't think what's the use of this. So please do it. Just like today, as we have discussed few questions before starting the class, before learning the new concept. Tomorrow also we are going to discuss these questions. Okay, all the 15 questions of page number 57, worksheet number 2. This we are going to discuss tomorrow. So please do it, and remember all the identities, right? All the identities, also start revising it, because all the identities what we have learned so far is going to be very useful. Okay, now as the lecture is ending, I'll be revising whatever we have learned so far. Let's just revise what we have learned today, and then we'll end the lecture. Okay, so the first thing we learned about is rational and irrational number. Rational number are denoted by what? Q and Q dash, right? And any number in the form of P by Q, where P and Q are integers, such that Q does not equal to 0, and all the integers, fraction, terminating and recurring numbers are going to be coming in what? A rational number. Okay, then the next one, irrational number, non-terminating and non-recurring number. Mostly inside the root or cube root there is a prime number. We'll say it's an irrational number. Apart from that, there are two special irrational number. One is pi, the other one is e, right? E's value is 2.713, and pi, everyone we know, 22 by 7 or 3.14. Okay, sum of a rational and an irrational number is what? Is irrational number, right? Sum of a rational and irrational number is what? Is irrational number. Okay, next we have learned that if A is rational and B is irrational and AB is rational, when A is equal to 0. That's the only possibility, that A should be equal to what? 0. Otherwise, the product is always going to be what? A rational number, irrational number. Okay, next, algebraic identities, right? So these are the identities in square we have learned today. A plus B whole square, A minus B whole square, A square minus B square, A plus B plus C whole square, and A square plus B square plus C square minus AB minus BC minus CA is equal to half of this. A minus B, B minus C, and C minus A whole square. Okay. Then cubic A plus B whole cube is equal to what? A cube plus 3A square B plus 3AB square plus B cube, right? Then A minus B cube will be what? A cube minus 3A square B plus 3ab square minus b cube. Okay, then the third one, a cube plus b cube is a plus b, a square minus ab plus b square, a plus b cube minus 3ab, a plus b, right? And a cube minus b cube will be a minus b, a square plus ab plus b square, a minus b cube, 3ab and a minus b. Okay. After this, there are two more identities. One is a cube plus b cube plus c cube minus 3abc. It can be written as a plus b plus c, a square plus b square plus c square minus ab minus bc minus ca, which can also be written as half a plus b plus c, a minus b square plus b minus c square plus c minus a square, right? Then the next point, which is a very important note, what is that? If either a plus b plus c is 0 or a equal to b equal to c, then and only then a cube plus b cube plus c cube is equal to what? 3abc. Okay. Then we have seen one more identity. We have seen the proof also. A to the power 4 plus a square plus 1 is equal to a square plus 1 minus a and a square plus 1 plus a. Okay. Yes. Then we have seen the value form. All right. So this is all about today's lecture. I think all of you understood it. Please do the homework. Again, I'll show you the homework. Right. Page number 57, worksheet number 2. All 15 questions are homework. Okay. So tomorrow we'll discuss. Okay. All the best. Thank you.